So we've learned about the coordinate plane. Now we want to bring our algebra into the fold and see what kind of insight into math we can gain from it. So let me start with a real simple equation. Y is equal to x plus 1. So here we have a multivariable equation consisting of a y and an x. So as we can see, our typical equations of class, we might have had something like x plus 1 is equal to 2. And in this case, we only have one solution, really. X can only, in order for this statement to be true, x can only be equal to 1. Because if x was equal to 5, then we would get 5 plus 1 is equal to 2, which 6 is equal to 2, and 6 is not equal to 2. But in this case here, we have an infinite number of solutions, because if I set x as equal to 1, then I get y is equal to 1 plus 1, which means y is equal to 2. But if I set x is equal to, we'll say 2 for simplicity's sake. So if x is equal to 2, that means 2 plus 1 is equal to y, so y is equal to 3. So that means I have, and I can do that for any number. I can do it for 10, I can do it for a million, I can do it for a billion, million, trillion. So I could do a billion, million, trillion plus 1, so that means y is equal to a billion, million, trillion, and 1. So I have an unlimited amount of true statements. So that is what's going to lead us to our graphing, so we can see all of our true statements at once. And from that, there's going to be a lot of different applications. We're going to be able to apply geometry to algebra, which is the most important part about graphing equations. So let's see how would we go about graphing equations. So the first method we're going to learn, there are a lot of different methods, but the first method we're going to learn is just plotting by points. So as I discussed earlier, for a statement of a multivariable equation of two variables to be true, we're going to need two values. We're going to need an x and a y. So let's start with our equation again. Let me write it over here. Y is equal to x plus 1. So let's make a table for values of x. So we're going to put in x values, and then here we're going to solve for our equation, and then here we're going to get a solution, a pair of numbers, an x and a y for the equation. So let's do minus 2 through positive 2, even though we already did them. So if we put minus 2 in, so y is equal to minus 2 plus 1, we're going to get, as a solution pair, we're going to get minus 2 plus 1, so y is going to be equal to minus 1. So that leaves our solution set as minus 2 minus 1. If we put in minus 1, y is equal to minus 1 plus 1. We're going to get minus 1 plus 1, which is 0. So we get minus 1, 0. For 0, we get 0 plus 1, which is equal to positive 1. So 0, 1. For 1, which we already did, I don't know why I keep doing that. 1 plus 1, which is equal to 2. So we have 1, 2. And then for the last one, y is equal to 2 plus 1, which is equal to 3. So we get 2, 3. So now, if you see, we have a series of ordered pairs, x's and y's. So that means we can put all of these points into a coordinate plane. So let me see if I can make a small one right here. Yeah, it should be able to fit. Alright, that's good enough. So 1, 2, 3, 4. We don't really have that big numbers. Alright, so let's start plotting our solution points. So for the first one we had -2, -1. So we go over to, alright, let me label our axes as x, this is y. So -1, -2, and then -1 for y. So here's our first point, right there. Our second point is -1, 0. So -1 for x and 0 for y. So that's right here. Third point, 0 for x, +1 for y. So 0x, +1, right here. Our fourth point is +1x, +2y. +1x, +2y, right here. And for our last point, +2x, +3y. So 1, 2, 1, 2, 3. So as you can see, a line is starting to form right here. So let me accentuate that with an actual line. So right along here we have a line. But this line doesn't just stop here. These are only the points that we graphed. If we continue on, if we put in 3, we're going to get 4. And this line is, as you can see, it makes contact with 3, 4 right there. So this line is a representation of the solution set for all the numbers. So if we follow, this goes to infinity in both directions, because we can put any x's and any y's in. And this is actually the equation of a line. And while we don't really talk about the properties of equations of lines right now, I'm just starting to talk about now just in order as a preparation for the upcoming sections where we do talk about lines. But what the graph, I guess let me just speak in generalities since we don't really know about lines yet. The graph of an algebra equation is simply the numbers that make the equation true. So if you notice, 0, 0 is not on this graph. So let's see what happens when we plug in 0, 0 into our equation. So let's put in 0, 0 for y is equal to x plus 1. So if we put in 0, 0 here, we're going to get 0 is equal to 0 plus 1. And that leaves us 0 is equal to 1, which is not true. So anything that is not on this graph, on this line, is not going to be true. It's not going to be a true statement if we put it in. We can try any of these points. We can put in 4, 0, we can put in 0, 4, we can put in -1, 1, we can put in 1, 1. And none of them are going to give us a true statement. So that is what the graph of an algebra equation means. It means these points, anything that it touches that is on the graph, is a solution for that equation. Well, let me do one more, just for a little variety, because there's all kinds of different equations. There's some, not all of them are going to be straight lines, and I'm going to pick one that's not a straight line. So let's do the same thing for y is equal to x squared. And you've probably seen equations like these before, but maybe have never seen the graph of one. This is going to be something that is not a line. So let's start with a table and see what kind of points we're going to get. So let's do x. So this is where we're going to plug in our x values. We'll do y is equal to x squared. And then here we'll get our x, y values. So let's do the same set of numbers again. -2, -1, 0, 1, and 2. We can pick any, but these are just small numbers, so we don't get an astronomical number, which we would get with this equation, as you'll see. So we'll put in -2. Y is equal to -2 squared. And remember, -2 squared is going to be a positive number because a minus times a minus is a positive. So -2 times -2 is equal to +4. So we get the point -2 +4. So for -1, -1 squared. And remember again, this is one of those things that's easy to mess up on, and it's very you need to make very sure that you don't make a very careless mistake like that, because it's very easy to do. People make them all the time, even people who have been doing math forever. So -1 times -1 is +1. So we get the point -1, 1. Y is equal to 0 squared. 0 squared is 0. So we get 0, 0. I forgot to put the equal signs there. Y is equal to 1 squared. 1 squared is just 1. So we get 1, 1. And then for our last point, y is equal to 2 squared. And 2 squared is +4. So 2, 4. So now let's take this information and put it on a graph. Oops. Alright. Alrighty. So we'll plot it in this color. Alright, so our first point is -2, +4. So we go on to, alright, let's label our axes. That's not a V. So -2, 1, 2, +4, 1, 2, 3, 4. So that point is right about here. Our second point, -1, 1. -1, 1. Our third point, it's nice and easy, 0, 0, right here. Our fourth point is 1, 1, so here. And our last point is 2, 1, 2, and then +4. So if you notice, we don't get a straight line. We get this sort of, I'm trying to connect these points, we get this sort of umbrella shape that's upside down. And this shape is called a parabola, and we're going to be learning a lot about these in upcoming sections. But this is mainly to show you that there are all kinds of different functions. You're not going to get things that are straight lines. You're going to get things that look like this. I mean, well, maybe not like that. They wouldn't cross over like that because this wouldn't be a function. But we'll learn about that later. But you'll get all kinds of crazy looking things. So when you're plotting points, if it looks strange, don't be concerned about it. There are a lot of very strange things in math. And this method will give you the graph of anything. So feel very confident in it when you are just plotting your points and connecting the dots. Whatever kind of equation is, it can be graphed using this method.